Very good evening to everyone, and I'm gladly welcomes you all for this wonderful session on power of artificial intelligence in an IoT. So it was organized by the IoT Lab and the Department of Electronics and Communication Engineering in association with NoviTech. So first of all, I welcome you all, and I would like to thank the advisory committee of this webinar, the Honorable Principal Dr. C. Palanisamy sir, and Dr. K. Sivakumar, Dean PDS sir, and Dr. S. Jagadiswaran sir, Professor of IC Academics and R&D, and the convener Dr. C. Pungodi madam, Head of the department, and the coordinators Mr. S. Tamil Selvan sir and Mrs. R. Rameswari madam and Mr. R. Ramesh sir. So Bannari Amman Institute of Technology. So in 1996 it was affiliated to Anna University. That institute offers 20 undergraduates and 15 postgraduate programs in engineering, technology and management studies. So all the departments of engineering and technology are recognized by the Anna University, and Chennai offered two PhD programs. The institution is accredited by the National Assessment and Accreditation Council with A grade, and most of the eligible courses are accredited by the National Board of Accreditation, so New Delhi. So also the institute is certified for implementing 5 years workplace management systems. Okay, so without delay, so let's enter to the topic: power of artificial intelligence with IoT. Okay, so here I'm G. Palanivel, Senior Project Engineer from NoviTech. So first I would like to introduce ourselves to all of you. So NoviTech is a technology company specialized in a product engineering with main focus to industries and automotive and robotics, industrial electronics. And we are doing a academic project training and development for both engineering and arts college students. Is it audible to all of you? Okay, thank you. So we are doing a academic project training and development for both engineering and arts college students in a variety of domains like artificial intelligence, machine learning, deep learning, and IoT and robotics, and industrial management and power electronics and the power systems, Java, Android applications, etc., etc. So and we are already conducting a lot of faculty development training programs in a variety of colleges in Kerala as well as in Tamil Nadu also. So and our main role, we are playing main role and our special in 100% hardware based hands-on workshops, so and in-plant trainings and the internships. Okay, so and our main branch in Ramnagar, Coimbatore, and our another one branch was located in Kallur, Kochi. Okay, so guys, if you are new to this channel, kindly subscribe our channel and click a bell icon for getting notifications about our upcoming webinars. Okay, so let's enter the topic. So this is our today's agenda. So first, the short introduction about what is smart agriculture, so and what is the condition of agriculture nowadays, and then we are moving to introduction about embedded systems and introduction about the IoT, Internet of Things, and then introduction about artificial intelligence. So and how the artificial intelligence interconnected with the IoT. So and some aspects of artificial intelligence like machine learning and deep learning. So here we are going to using the machine learning algorithm for this process. So the short explanation about machine learning and machine learning algorithms, and after that we are going to the hardware parts. So hardware explanation and the demonstration. So it's especially for agriculture oriented with artificial intelligence, and next collect the data from the agricultural sensors, and using by this IoT data, so we are going to apply the artificial intelligence in our smart agriculture. So this is our agenda. So I hope all of you satisfied with this agenda. So let's move to the agricultural. Okay, so as a lot of we might know, in 2050, so upcoming, we need double the amount of food than what we have today. So that has mainly two reasons. So first one is a populations. The population on the world keeps on increasing. It is going to be around approximately 11 billion by 2050. So this is one of the reason, and then because we have a upward social mobility, so as people get richer and they need more food per person. So these are the main two reasons. But that resources that we have to produce the food, it's also decreasing. Okay, so that resources we want to increase our food productions, that is decreasing. So what are the some resources means? First, the forest. So the density of forest and the density of trees is almost decreased. We all know about it, and we all are facing some problem in some few months ago. So there is Amazon forest, the firing. So most of the forest and most of the trees are almost decreasing. So the first available amount of groundwater is going down. Okay, so this is the one reason. And then the another one important reasons, all the land that was splitted for agriculture is shrinking. So because towns and the cities are expanding, and it takes most of the agricultural land. Okay, so we have these types of two main aspects. So these resources going down regularly. Okay, so for reduce these kind of problems, we want to mindful of our environment. So and then we can rectify this problem with some suitable ways. Okay, so but nowadays this is a very big challenge for as a human. Okay, so when we talk about our traditional farming, we need to treat our entire farm as one single unit. So just assume if government gives us some amount of water for agriculturing, so we are going to take this water and apply this water uniformly to across the field. But this is not the right way for our current situations. So because some of the places of field requires a low amount of water, and some of that field requires high amount of water. So based on this requirement, based on this water requirement, that moisture requirement, we need to supply the particular amount of water for the particular fields. Okay, so we need to use the water sparingly. And next, higher cultivation in less arable land. So we have a less amount of agricultural land. So using by this less amount of land, we need to create the higher cultivations. Okay, so and decrease the time duration of agricultural process. We need to decrease the time duration of every agricultural process. So we need to replace the human with a machine. So definitely it's need. So we need to replace the farmers with the machines. Okay, so the farmers and innovators alike will have to come together to put in place strategies to help farmers to meeting a increasing production of food demands. So with many pain points for farmers, such as little additional land and some extreme weather conditions and some natural disorders, so and climate changes and natural environmental changes, so and farming practices are becoming harder. At that critical situations, we are in need of some technologies. So technology is only the solution for this kind of problems. Those technologies find the exact solution for this type of problems. So first, here we introduce the embedded system. So we are going to apply the some hardwares, some sensors to the agricultural field. Okay, so embedded system means it's nothing, it's simple hardware and the software. We all know about it, about this embedded systems. So in this process here we need some input data and some one processor, and we need some output. So for example here I'm take a one processor, so and I take a sensors as a humidity sensor. So that humidity sensors means it's sensing device, it's getting a informations, it getting a knowledge from a environmental. So as per the sensors modules, if you are using the humidity sensor, it will identify the humidity level of surrounding, and if you are using the temperature sensor, it will identify the temperature level as like that. So these all the data is going to the processor with a wired connection, and that processor analyzing this data, and it gives us some command to the output actuators. Okay, so for example here I'm using the LCD display. So with this humidity data and the temperature data, so and some moisture content data, so these all the data are displayed in a LCD. So we can easily get the humidity values and the temperature value using by these types of technology. Okay, so let's enter the hardware. So how to interface the sensors with the processors and how to get a output. Okay, so for this process here I'm take a Raspberry Pi as our processor. Okay, so Raspberry Pi, all of you know about it. So already we are conducting a lot of webinars related to this Raspberry Pi and the IoT. So just go through our channel, you can get a clear idea about this Raspberry Pi. Okay, so for reference that, just I'm giving some introduction about this. So this Raspberry Pi, so this is the Raspberry Pi 3 model B. Okay, so and this Raspberry Pi 3 model B has a 4 number of USB ports, and it has a one Ethernet port for connecting the network connections, and audio output and video output, and it has some main processor. This is the main processor. So here we need only this GPIO pins. Okay, so because all of we know about it, this Raspberry Pi is a critical size CPU. This is the only CPU have a GPIO module, GPIO pins. If you take your laptop or computer, so you can't able to connect any of the sensors or actuators with your CPU. So but this CPU has these specifications. Okay, so that's why here we choosing this Raspberry Pi as our processor. Okay, so just to explain about this GPIO, it is very important for writing a program. So it has a 40 number of pins, and these all the pins are in a digital, and so in this 40 pins we have a 4 power supply pins, 2 for 3.3 volt and 2 for 5 volt, and 8 number of ground pins, and remaining all the pins are using to GPIO connections. Okay, so I already told these all the pins are only for a digital communications. We can't connect our any one of the analog sensors or analog actuators directly to the Raspberry Pi, but we need to connect that. So that's why here we using the another one module, ADC. So using by this ADC, analog to digital converter, here we need to getting a analog sensors data as a analog input, and this analog input is converted to the digital input, and this data is getting from the ADC using by the SPI protocol. Okay, so just see, so these blue color pins are the SPI communications pins. So 19 and 21 and 23, 24 and 26, these are all the SPIO communications pins. Okay, so and then for getting an input and give an output, here I'm using these types of sensors. So first here I apply the moisture sensor for getting a moisture content, that soil moisture content, and next the humidity sensor, it's identify the humidity level of surrounding, and next temperature sensor, what are the exact temperatures now, so we can identify this. And as I'm told already, it's all the sensors are the analog sensors, so it gives us an analog. Okay, so but Raspberry Pi is only for digital, so that's why we are using this MCP 3008. This is the ADC. Okay, so now after getting a values, we need to apply the some algorithms, some programmings. Okay, so using by these programs, we need to actuate our pumping motor. Okay, so these are very basic things, embedded system. So now, so let's enter to the hardware part. So I will show the hardware. So here I'm set up some hardwares for agricultural. Okay, so it's a Raspberry Pi, and here I have a one relay. So this relay for activating the motor, and this is the ADC MCP 3008. So and here we are using three types of sensors. This is the temperature sensor, and this is the humidity sensor, and this is the moisture sensor. Okay, so here we have a cup of water. So for sharing this to the some land, agricultural land. Okay, so and these all the sensors are connected to the ADC module, and from this ADC we can get a digital output. So digital output of this sensor. Okay, so and we are actuating some actuators using by the program. Okay, so these are our basic hardwares. Okay, so Raspberry Pi is one of the CPU, no? So if you want to connect the Raspberry Pi with our PC, we need some VNC. So just here I'm connect my Raspberry Pi with a VNC viewer. So so here I'm open my folder. Okay, open program for getting a sensors data. So because this Raspberry Pi 3 model B has only 1 GB RAM, so it's maybe some this program. Okay, so import time and import SPI dev. So SPI is a module file. So SPI dev is module file, and next from the SPI dev, here I'm using the functions, call the functions, and I store these all the functions into the SPI, and here I'm enable the SPI to open of 0,0. So this is the SPI enable line. So and this is the functions, and this also the functions. So using by these functions, we can get the sensors data as analog, and it's converted to the digital. So for this process here I'm using the X2 function. Okay, so here we need to convert our 8 input into the 4 output. So that's why here using the multiplexer and demultiplexers. So and after getting a ADC value as analog value, so it gives us some 11 bits of data. 11 bits of data, we need to convert this 11 bit into the 8 bit. Okay, so that's why here we using the AND 3 operations. So using by these AND 3 operations, we can get exact 8 bits. Okay, and this 8-bit data is written for this from this functions. Okay, so after getting a data, so using by this analog data, we are going to convert this data into the voltage. So for that process here I'm give a voltage 3.3 volt, and next float of 1023. So this is our highest value, highest analog value. Okay, so and it's converted to the voltage, that's all. Okay, so the simple program. So because here we choosing the Python program for this process. So just I'm give a while loop. So and from this here have a one variable. So noise is equal to analog input of 0. So because here I'm connect my moisture sensor into the 0th channel, as like temperature to the analog input of 1. So analog input of 1 means it's the first channel, and next humidity, so it's the second channel. Okay, so just I give us some circuit diagram. Okay, so and these values, moisture value and temperature value and humidity value is displayed, depends upon this. Okay, so I'm draw a circuit diagram with the fritzing. So how to connect these types of sensors with using by the ADC to the Raspberry Pi. Okay, so here I'm just open my Raspberry Pi module. Okay, so and after that we need some ADC. So I'm given MCP 3008 IC here. So I take this. Okay, so that's simple. These are all the 8 pins are for channel 0 and channel 1 to channel 7. So these are for connected to the sensors. So all the sensors are connected to these channels. Okay, so and after connecting this, so we can get our output data from this clock pin and this D out and this D in pin, so and the meso pin. Okay, so and here this clock pin is directly connected to the GPIO 11. So because this is our SPI protocol pin. Okay, so this is a GPIO 11. So it's a clock pin. So here I'm connect this. Okay, so as like that, this is for GPIO 9. So and this for GPIO 10. Okay, so and this is for GPIO 8. So now we are successfully connect the MCP IC to the Raspberry Pi with using by the SPI protocol. Okay, so and this is for a ground supply. And this also for ground supply, and this pin is for also ground supply. So it requires only the 0 voltage, that's all. So and this is for 5-volt power supply. So here I'm connect the 5-volt supplies. Okay, so that's all. So these are the connections, and after that we need to connect our sensors. So just I am open my temperature sensor here. So this is for 5-volt, so that's why I am connect directly to the 5-volt, and this is for output, so I connect this into the output. So and then this is for ground, so it's like I connect it to the ground. Okay, so using by this method, so we need to interface our humidity sensor and the moisture sensor as well as. Okay, so and after here we are applying the one output, so that is a relay. Okay, so the relay is used to control the motor, as we know. So just time open a relay. Okay, so this is very useful. Okay, this is the relay. So I take a one motor, DC motor. So and we need one power supply for this. So why we are using here this relay for this means, so because for every motors we need a 9-volt power supply. This is minimum. So but our Raspberry Pi gives us only the 5-volt. So we can't run the motor using by this 5-volt. So that's why here I'm using the relay. So relay is one of the switching device. No? Okay. So and this is for 5-volt. So I directly connect it to the 5-volt. So and we need to give a data. So after giving a data, so that relay will be activated. So for this process, we need to give us some. We need to use the resistors. So that resistors. So here I'm taking a 1 kilo ohm resistor. Okay. So and we need another one switch. So that's why I'm choosing the transistor. Okay. So now this resistor was connected to the base of this transistor, and this is connected to the relay. And here I'm given some ground supply. Okay. So and I connect this resistor into our GPIO 21. Okay. So GPIO 21. So why are we using these transistors means, if you are giving any one of the data here, for example, the data is either a 0 or 1. Okay. So if you are giving a 0, so this ground supply is not moving to this. Okay. But if you are give a high voltage, if you are give a 1, then this transistor is allows this ground supply into this relay. So after getting a ground supply, that relay will be activated. So this magnetic coil will create the one magnetic field. So that magnetic field was used to observe this key. So and after giving a one command to this resistor and transistor, and it will transfer the ground supply to the relay. So after it was created the some magnetic pulse, and this magnetic pulse was absorbed the key. After this key touching this unit, this ground supply is moved to the motor. Okay. So once again, so this is the connections for relay and the motor. Okay. So let's check with the programming. So just I'm run this code. So these are our datas. Okay. So see, so it's continuously gives us a humidity values and moisture values under the temperature values. No. So so this temperature value and the moisture value and the humidity value. So because moisture and humidity, it's identify the same content. So that's why here we have some same values. So and this temperature, so this is analog value. So this is our normal temperature. Okay. So this embedded systems is only used to identify the surrounding. So using by the sensors. Okay. So that's all. So and then if you apply this embedded systems into our field, so it covers it covers only the some few ranges of field. So for cover up the full land, we need more number of setups and need many wide connections like this. Okay. So because it captures the some analog values from environment and it displays, that's all. So if you want to know about these values, you need to enter the field and you need to watch every LCD displays or the some system monitor. You can get the values about this moisture content and temperature and humidity content. Okay, but so this is not fair. So we need to analyze these values from everywhere. Okay, so for this method, here we need to replace these wired connections into the wireless connections. So the ever best wireless technology is a internet. We all know about it. Okay, so we need to connect the internet of things. We need to connect interface this technology into our embedded systems. So then we can get our sensors data and we can monitor our sensors data from everywhere. Okay, so and this internet of things means it's nothing, so it means taking all the things in the world and connecting them to the internet. Okay, so for example, if you are need to get some informations about the soil means we can interface the sensors and these sensors capture the values and is uploaded to the cloud using by this cloud server, so we can monitor the soil from anywhere. Okay, so now so we are connecting our normal soil into the internet, so that's called internet of things. So we can connect the each and every things to the internet. Okay, so in IoT based smart farming, so a system is used to build for monitoring the crop field with the help of some sensors. It may be a humidity or temperature or anything, any one of the sensors we can get some outputs. Okay, so and the farmers can monitor these field conditions from anywhere. So this IoT based smart farming is very efficient one when we compared with a normal conventional approach. Okay, so for this process, it has a three. First one is the data collection and the communication and visualizing. So this is the basic three process in an IoT. So data collection. So first we need to gather the data. So after getting the data, we need to share this data to any one of the device, any one of the things which was located in another place. So for this method here we using the some wireless technology that's called internet. Okay, so and before IoT, so we all are using only the Bluetooth or Wi-Fi, like that means, but that Bluetooth and Wi-Fi, it has some restrictions. Okay, so and it has only the some small amount of ranges. So we need we can monitor only the some limited ranges. Okay, so but here we need monitor from everywhere, so that's why we replace this Bluetooth and Wi-Fi and wired connections with the internet of things. Okay, so and after getting the data, it's a visualizing. So visualizing means it's nothing, so we need to view the data using by the some GUIs. Okay, so some graphical user interface. So whenever we see this data with a graphical user interface, we can get a clear idea about it. Okay, so from sensors, it's collected the data and send it to the processor, and from the processor we are going to apply some clouds. Okay, so for this process here we using the MQTT cloud. So okay, so this is one of the protocol, and the main operation of this MQTT is collecting the some sensors data. Okay, and it will publish to the MQTT broker. Okay, and if you are the subscriber means for example, we can subscribe this MQTT using by our laptop or our mobile devices also. Okay, so first you need to subscribe the MQTT broker using your laptop or mobile device, and then if you are a subscriber, then this MQTT broker will publish the data to all the subscribers. Okay, so it's collecting the data from this temperature sensor. So here there is a only two methods. First one is a publish and the subscribe. You need to subscribe, and then after subscribing you can get some informations about this MQTT broker data. Okay, So this for only getting some sensors data, that's all. So next we are going to send this data to the MQTT broker. So that is Internet of Things. So here we are enter the Internet of Things. Here we are going to apply the Internet of Things for us some small sensors. Okay, so some simple sensors. As I'm told already, so we need a one server. So just I'm import one module file that's called paho.mqtt.client. So simply I mentioned this module file as a paho. Okay, so and next publish. So this is for publish the data. So inside of that publish functions, here I'm give a client and user data and the medium. Okay, so and after inside of that it's print to the some dim level. Okay, so and here I'm created the one client using by the paho module file. So from that paho, so here I'm called the client functions. This has a client features. Okay, so these are all the functions are stored to the client. Okay, and client on publish is equal to on publish. So simply I am call this function and store this function into the client dot and publish. So and connect. So this is one of the function, and this functions to connect with the broker and the connections between the broker and client. So using by this server. So broker.mqtt-dashboard.com, and this is the port address. Okay, so and client dot loop start means so it will be continuously uh, connecting to this server using by this port address. Okay, so the same method, so getting analog input and convert it to the voltage. Okay, so after getting a data, so here I am simply apply this data into the some broker. Okay, so here I'm using the some delay, so time dot slip of 2. So every 2 seconds, so it will be uploaded to the subscriber. Okay, so all the subscribers you need to create the some server. So using by this server address and the port number, and after subscribe that we need to give this title. So this is our title. So sensor slash attempt and sensor slash moisture and sensor slash humidity. So these all the titles is carry the sensors value. So if you are using this sensors temp title, you can get this temperature value. If you are using sensor slash moist title, you can get this moisture value. So it's like humidity values. Okay, so just here I'm open my MQTT application. Okay, so and in that MQTT application, so just I'm give it, I show you my mobile using by the Google Meet. Okay, so I'm open that. So for showing my mobile, that's all. Okay, okay. So here I'm open my MQTT applications, and this is our my MQTT application. So here we need to click our setting. Okay, and in that setting we need to give our broker URL link and the port address. Okay, so our URL link is broker.mqtt-dashboard.com. So broker dot, I just enter it. Okay, so I am just save this. Okay, so and here I am connect this. So after connected, so we can verify these connections using by this green color mark. If it is a green color mark means so it is successfully connected to our broker. Okay, so and next we need to subscribe. So for this subscriptions, so here I am click a subscribe and we need to enter the title. So enter the topic. Okay, so here we have a 3 topic. So sensor slash temp. So sensor slash temp. So just I am add that, and next sensor slash our moisture content. So sensor dot moist, I add that, and then sensor slash humidity. So hum, I add that. So here I am successfully subscribed to this broker. Okay, so and next this dashboard. So we can get our data in this dashboard. Okay, so now we didn't get any data. Okay, so just I run that code. Okay, so here we need to install our PAHO module file. Okay, so for that process, here we open some Linux terminal. Okay, so Linux terminal. So because this Raspberry Pi is a Linux based OS, so it has one of the OS Raspbian Jessie. So it's a Linux based OS. Okay, so if you want to install, or if you want to access any one of the data in the admin locations, so we need to use the one of the Linux command. Okay, that's called sudo. Sudo means it's nothing, it's a super user do. Okay, so just give a sudo command, sudo apt-get install. So mosquito, so this is one of the module file for enabling our MQTT. So it's take us some time. It depends upon the internet connections. Okay. Okay, so it has a lot of commands. It's like ls means list out our folders and files, and cd for change directory, and pw for present working directory. So these are the lot of Linux commands. So here we using only the sudo super user do for getting a permissions from our admin. Okay, so and after installing the mosquito, so we need to install our Pego MQTT cloud. So for this process here I'm using the, this is one of the package, so that's why I'm using the pip command. So pip means it's nothing, Python installation package, that's called pip. So sudo pip install payhouse/mqtt. Sorry, payho-mqtt. Okay, so it's successfully installed, and so we will check that. So just time import payho.mqtt, so it's for some checking purpose now. So payho.mqtt.client. Okay, so that's no error, so we successfully installed the mqtt, so in our Raspberry Pi. So again I run that. So just I open my MQTT. So in that dashboard, so here we get a notifications, so about the values. So just see, maximize this, the sensor humidity, temperature value, humidity value. So local network, so we can get these values from everywhere. So now you can also get these values, these sensors values here. So you can also view this data in your MQTT applications. Now also you can see that values. So okay, so using by our server and the support number, so that is a 1883. Okay, so simple. So here we visualize the data, so some simple manner. Okay, so then we need to visualize our data, so using by the some graphical method. Okay, so that's why, so things speak. Okay, so I hope all of you understand this MQTT data updation. So if you have any doubt about this MQTT, so just mention it in a chat section, so I will reply you at the end of the session. Okay, so this is for MQTT, and next, so we are going to upload this sensors data to the ThinkSpeak cloud. Okay, so ThinkSpeak, I hope all of you know about this ThinkSpeak cloud. So okay, so just I open my ThinkSpeak. So we need to create a one new account here. So I already created the account. So just I open my channels. Okay, so click a new channel. So for creating the new one, so agriculture. So here I'm simply give a name as agriculture. Okay, so smart agriculture, no? Okay, so field 1. So let's check the program. So field 1 is a temperature, and field 1 is a temperature, and field 2 is a moisture, and field 3 is a humidity. Okay, so based on this temperature and moisture and humidity level, so we need to apply this all the data into our channels in every field. So temperature and then humidity and next moisture. Okay, so just I save this channel, and after creating the channel we get a API key. So there is a two part of API. One is for writing API and another one is for read API. Okay, so we all know about this purpose of write API and read API. So once again explain this. This write API is used to upload our sensors data to the cloud. Okay, so upload our sensors data to the cloud, and this read API key is used to getting the sensors data from the cloud. Okay, so here we need to apply this data into the cloud. That's why we are using this write API key. Okay, so just I change this API key with our new one. Okay, so just I save that. So that's it. So field 1, this temperature data is applied to the field 1 and as well as the moisture and the humidity data, and using by this key. Okay, so here we pass the key value and this key value is taken from here. Okay, so that's all. So and these all the lines for reach the server and open our exact account and apply the values into that particular field. So these are the lines for that. So that's why we are using the HTTP. So this is for website opening. So if we want to access any one of the website, we can use this HTTP lib. And if we want to use any one of the URL link, we can use the URL lib. Okay. And if there is any error in these connections, so finally we get some connection failed. So that's why we are using the try and except here. So this is the exception handling method. We know about it. Okay, so just I run that code. Okay, so let's check the channel here. So private view. So the data was uploaded here. Temperature is 70 and humidity level is 1003. Okay, so let's see. So let's see the some moisture value, and here I'm touch the moisture sensor. Okay, so because this also analyze our hand moisture values also, na? So I'm open this. So here I'm have some moisture sensors. So this moisture sensor is dipped in a soil. So just see the moisture value. It gives us a 1002. Okay, and if I'm touch this value, it will be reduced. So moisture is 936. No? So 900. So it will also identify our hand moisturizing also. Okay. So if you are supply the any some of any water, so it will gives us a very less amount of. So using by this data, so we need to create our data sets. Okay. So I will explain this in a later. So and let's check this with the thing speak. So it's reduced. So see the humidity value is updated normally, and if it is reduced mean, so it will plotted here. So and again it will be increasing. Okay, so and just like the moisture contents also. Okay, so now we get some visualization data. Okay, so from this visualizing method we can easily get our data. So it's very easy to understand these data. Okay, so that's why we are using here this method. Okay, so but this is only for applying the IoT. Okay, so when we are using the IoT with embedded, we can get the sensors data and we can monitor this data from every from anywhere, any one of the place. Okay, so that is the main purpose of this IoT. So here after collecting this data, So we are the human being, we can easily get some knowledge from this data, and based on this knowledge we need to activate some actuators. Okay, so for example, so temperature is a some 70 and humidity level is a 1000, and this also the 1000. So based on this data, as per our human intelligent power, we need to turn on our motor. So we need to turn on our motor, and we need to set the timing for this motor. Okay, so but this is one of the manual interruption. So our main motto is replacing the human with the machines. So this is our main motto, so that machines need some intelligent power. Okay, so intelligent power, so we need to give a intelligent power to the machine with artificially. Okay, so that's called artificial intelligence. Okay, so let's talk about an artificial intelligence. After applying the artificial intelligence in your IoT, that closes the loop. So because it's collecting the data from sensors, and it's analyzing, and finally it's displaying in one of the website or one of the cloud. Okay, and after it's automatically get a knowledge from this data, and it's automatically turn on the motor as per the sensors values. Okay, so now this action was closed. Collection, communication, visualizing, and acting. So again it's collection, communication, visualizing, acting. So this loop was closed by the artificial intelligence. Okay, so let's talk about the artificial intelligence. Okay, so and things big. Okay, so artificial intelligence, so it means I think that the machines are programmed to think like a human. Okay, so and it's always mimic the human actions, so based on the input data. Okay, so that artificial intelligence is the next huge development in the technical world. So we all know about it, so that upcoming worlds is only depends upon the artificial intelligence. So now all the companies, all the famous companies are give a retirement to their employees, and replace the employees with the machines. Okay, so it's like TVS. So and most of the automobile companies, the only that automobile companies replace the human with the machines. So most of the companies choosing the artificial intelligent world, artificial intelligent technology. Okay, so so we can actually make a machines can mimic a human actions. I already told about that, using by the some data. For example, we are the humans, or if we want to get some knowledge, means we need some experience. Okay, so experience, so based on that experience we can get some knowledge. Okay, as like that, that machines also get a knowledge from the experience. So but that machines don't know the experience, don't have experience as like human. So because that's one of the machine, that's all, that knows only the 0 and 1, power supply on and power supply off, that's all. So based on this 0 and 1, that binary conditions, we need to give our experience, we need to give our experience and convert it into the some binary word, and after this binary is feed up to the machines, and based on this fine binary experience, that machine can get a knowledge. Okay, so experience is taken from the sensors, and it's converted to some digital, and this digital is applied to the machine, and using by the some algorithms, so we can analyze the experience data. Okay, so this application of artificial intelligence with IoT based smart farming, so not only for target conventional, so it's for large farming operations. So but could also be levels of uplift growing of the agricultural and common trends in agriculture, like organic farming and family farming. So organic farming and family farming means it's nothing. So family farming is so how what to do. So it's a simple. So we are farming with a some small amount of land. So for example, in our home. Okay, so so in our home, so in our terrace farming, we all know about the terrace farming. So it has a minimum amount of land, but from this land we need to get some more amount of cultivation. Okay, so for these types of process, we can use this artificial intelligence method with artificial intelligence with IoT method to the agricultural. Okay, so that all the industries and agricultural industries are also turning to the AI technologies to help yield the healthier crops. So for example, so we all are in a busy world, okay, so but we need some food, but that agriculture land and the water level is also decreasing. So the only reasons we need to produce our self need, okay, we need to produce our food and we need to produce the groceries, okay. So we all are need a some terraforming method, okay, so but we are in busy, so we can't continuously monitor these terrace plants or some plants like that, okay. So here we applied the one of robot, okay, so that robot can identify the moisture level, and so based on that moisture level and temperature level, it automatically analyzing how much of water we need to give that to the plant after. So not only this purpose, if any one of the plant was affected by the disease, any one of the leaf disease, that image processing method, it's one of the artificial intelligence concept, so image processing, so OpenCV, so using by this image processing we can easily identify our leaf diseases also, okay. So and so every one of the plants have some different types of diseases, so based on our data sets, based on our previous leaf diseases data sets, we can easily segregate the and we can easily characterize the diseases, okay. So for example, we know about the recognition method, face recognition. So the initial stage of face recognition is only this method is used to identify the face, that's all, okay. So if you are in some crowd, so that face detection method is using to identify our face only. After updating this algorithm with artificial intelligence, it's accurately identify the person name of that face, okay. So that's called the person recognition. So identifications is different and recognition is different. Identifications means it only identify, recognize means it recognize the more types, so okay. So using by this artificial intelligence, we can easily um, um, recognize our leaf diseases, and depends upon that disease we can fertilize the fertilizer, so we can spray the fertilizer for the particular leaf, okay. And these all the data are shared with our mobile using by the IoT technology, okay. So using by this AIoT, artificial intelligence with internet of things, so we can yield the healthier crops, okay. So and this is using for the some family farming also, okay. So and it's used to help with the workload, okay. So it's reduce the humans work, okay, and improve the wide range of agriculture related tasks, so in the entire food supply chain, okay. So we need this artificial intelligence with IoT in our current agricultural domain, okay. So this artificial intelligence means it's giving us some intelligent power to the machines, that's also. This is the basic definition, and this artificial intelligence has a two parts, okay. So first one is a machine learning and deep learning. So just see this slide. So get a healthier crops, so and this I am told. So this drone will automatically identify the leaf disease and it spray the some particular amount of fertilizing to that leaf, to that plant, okay. So this is one of the artificial intelligence method, and here, so this is for identify the weed killing, okay. So if you were plant any one of the tomato or potato, any one of the plant, organic plant means, so definitely, so there is some weeds are growing, no. So based on using by this image processing technology, we can easily identify the weed also, okay. So after identify that robot arm is automatically killing that weed, okay. So this is a weed killing process. And next, so this is for checking the some soil content, that's all, okay. Soil content and the grow of the plant, okay. So these are the some few examples of artificial intelligence in agricultural world. Okay, so in this artificial intelligence, as I'm told already, it has a two subsets. The first one is a machine learning and deep learning. So machine learning means it's nothing. So it's getting a some knowledge from our previous data set, and there's some algorithms. Okay, so this is one of the subset of artificial intelligence. So that provides a system that ability to automatically learn. Okay, so it's automatically learn and improve from the experience without being explicitly programs. So because all the programs in a backside. Okay, so it automatically provides the system to ability automatically learn and automatically update that oneself. Okay, so this machine learning focuses on the development of computer programs that can access the data and use it to learn for themselves. So this primary aim is to allow the computers to learn automatically without human intervention. So this is the main motto of this machine learning. Okay, so and this machine learning has a three types of three types. The first one is a supervised learning, and another one is unsupervised learning and reinforcement learning. Okay, so supervised learning means it's nothing. So as the name indicates, so this supervised learning have a some supervisor or some teacher. Okay, so basically supervised learning is a learning in which we teach or train the machine using by the data. So which is well labeled. That means some data is already tagged with some correct answer. So for example, if you are given some features of leaf, okay, so features of leaf, and this leaf is mentioned as a disease 1, and you give another one input image, so this have another some features. So these types of features are labeled as a the second disease. Okay, so this uh, labeled data so are trained using to train to the machine. So that machines can training with the labeled data, so with the some under supervising is compared with the previous data set. And if it was matching with any one of the previous data set means, so it's exact, it's take that label and give us to the give us as a output. Okay, so that is a supervised learning. Okay, and unsupervised learning, so it's a direct opposite for supervised learning. So because there is no any guidance. Okay, so that unsupervised learning is the training of machine using informations, so that is neither classified or labeled data. Okay, and this algorithms is to act on that information without the guidance. Okay, so here the task of this machine is to grouping the unsorted informations. Unsorted means it's unlabeled image, unlabeled data. So unsorted informations according to the some similarities and some patterns and some differences. So using by this similarity, patterns and the differences, so it will be grouping the unlabeled data. So that's all. This is a process of unsupervised learning. No? So these are the very few the major learning process in a machine learning. So another one is a reinforcement learning. So it's only depends on the feedback. Okay, so let's enter to the artificial intelligence, how to apply the artificial intelligence to that agricultural. Okay, so and for this process here I'm take this type of features. First one is the moisture level and temperature level and humidity level and the duration means it's nothing. So that planting time. Okay, so that's all. So here we take these four features. Okay, so just I close that. So for this process, so we are getting the census data, and it was uploaded to the some cloud, ThinkSpeak cloud. And after this process, we need to get the data from the cloud. Okay. So and before that, So it's very okay, it's very important. So what are the algorithm we are going to apply to this agricultural? So here I'm choose the KNN algorithm. Okay, so there is a very simplest algorithm in a machine learning. So it is for it is under the supervised learning. Okay, so because it has some labels. So and this is using for a classification and regression and outlier detection. So already we are explaining this KNN clearly in our previous videos. Just to go through it, so you can get some ideas about it. Okay, so and guys, if you have any doubt about this session, so just mention it in a chat box. Okay, and if you like this, just click a like button. Okay, so k nearest neighbor, so it's like that name indicates, so we need to analyze the nearest neighbor. So for example, so here we have a class A and class B. So just I remind that KNN algorithm how it will be working and how it find the distance. Okay, so so for example, here I'm take this temperature value, tag this x1 as a temperature and x2 as a moisture. Okay, so temperature value and moisture value, and this is the class. So 30 and moisture value is of 40 means, so that class is a normal. Okay, so normal. So it's like this is a 40 and this is the 60 means, so that is the abnormal condition. So class A and this is a class B. Okay, so here we simply plotted these values into the graph. Okay, so and here after applying the previous data set values into the graph, so it will be like that. So this yellow color mentioned as a class A and this for class B. Okay, so and then after that we need to give us some input data using by the sensors. Okay, so this input data is like temperature is 35 or and moisture level is a 45 or 50 means, so definitely it will be plotted here. Okay, so this star is a red color mark, it's mentioned as a new data. Okay, so after applying this new data into the graph, so it will have some nearest neighbors. Okay, so for identify the nearest neighbors we have some algorithms. Okay, so some methods, a distance finding method, Euclidean distance. Okay, so it has some formula, and using by this formula we can identify the distance. So for example, so it has some so so for real time, so for it has a 3 centimeters means, and this is a 4 centimeter, so this is a 4 centimeter and this is a 5 centimeter. Okay, so and this is the 3.5 and this is the so 3.4. Okay, so here I'm set the k value, this k value is 3. So 3 means it's only take the 3 nearest neighbors. Okay, so 3 nearest neighbors based on the distance. Okay, so and inside of that circle here we have a one number of class A and two number of class B. Okay, so the majority is a class B. So our new data is definitely has a label, definitely it's labeled as a class B. Okay, so this is the k nearest neighbor, and this is for only the linear types of data. Okay, so and here I'm going to explain about the another one um, algorithms. There is a support vector machine. Okay, so supervised learning algorithm, so this is also under the supervised learning because it also has some labels, no? So and this is for also classifying and regression and outcome. So what are the difference between this KNN and support vector means? So that KNN it gives a accurate output when we are giving us some small amount of data set. Okay, but the support vector machines, it's didn't give it can't give us a accurate output when you are giving a small amount of data set. So for applying these support vector machines, we need to give a lot of data sets, and this is also capable for operating with the linear data and the non-linear data. Okay, so linear means linear and the non-linear means nothing. So because this is medium level and high level, so video has a low level and this is also low level. Okay, so these types of data is have only the same similarities. Okay, and this has some same similarities. So highest x value and the lowest y value, and it's some highest x value and the minimum y value. So it's like, so this is the minimum x value and highest y value. So it has some similarities. So using by these similarities, here we split it up with some single line. Okay, so this single line is plotted for using, it's take a two separated class data, and it will be find out the medium. It will find out the medium point. So based on that medium, here it was plotted as a line. But sometimes that data are don't have any, if it was didn't have any similarities means, so we can't apply the KNN algorithm to these non-linear datas. Okay, so simply, so this is the medium feature, sorry, medium x value and the medium y value is only, it's mentioned as a one label. Okay, and low level of x value and low level of y value is also mentioned as a label. At the same time, so high level of x value and high level of y value is also mentioned as a label A. So here we have a two types for label A. Okay, so this called the non-linear separable. Okay, so for this non-linear data, here I'm identify the medium point. So at the same method which we are using in a linear separable. Okay, and based on this medium level, we need to circulate, we need to draw the circle for the for out of this class A and the class B. Okay, so this is the class A and this is for class B. Okay, so if you are given any one of the new data means, it's definitely applied in a class A circle or class B circle. Okay, so if it was applied in here means, it's definitely mentioned as a class B, and if you are applied here means, so it will be mentioned as a class A. Okay, so this is a support vector machine. So let's check the some accuracy about KNN and the support vector machines. So because, so I already told that KNN algorithm gives us the exact output when we are given a low amount of data set. But if you are given low amount of data set, that support vector machines was failed in that process. Okay, so that's why here we using the KNN and the support vector machine. Okay, so for this process, here I'm called the two algorithms, to both of the algorithms. So this linear SVC, so this is for the SVM classification, and after that here I'm called the KNN algorithm. So this is for k nearest neighbor. Okay, so and JSON and URL libdo. This JSON is nothing. So we need to get our sensors data from the cloud. No? That website gives us some JSON file. So we need to extract our sensors data from this JSON file. So that's why here I'm import the JSON. So and this is our read API key. Okay, so for reading the data from sensors, and we need to give our channel ID. Okay, so if you want to give a if you want to access the data, so because it's very secured data, so if you want to access the data means we need to give a channel ID. Okay, so and after that, so I already told we need to give us some experience, some digital experience to the machines. So that's why here I have a one data set. So this data set is in a format of CSV. So this data set have a some lot of experience. Okay, so this experience, this data set is created by the manual. Okay, so just I give us some manual values for this process. Okay, so these are the moisture value, and these are the temperature values, and these are the humidity value. Okay, so and this is the time. So time means, so what are the timing it's take, so it's having a from planting. So this is the time, it's a 1 month, so from planting, and this is the 2 month for from planting. So and this is the 3 months. So because if you are take a paddy field means, paddy field, so that paddy requires a more amount of water when it is in a normal stage, when it is in a initial stage. Okay, so we all know about it. So that paddy field requires a more amount of data when it is in a initial stage, but after some days, After some days it requires some normal amount of data, and after the finishing level, so we don't need to give us some water to that paddy field. So this water supply is also based on the timing purpose also. Okay, so that's why here I'm have some time. So it's on the month, so it's a first month and it's a second month and it's a third and the fourth month. Okay, so moisture level and temperature level and humidity level, and based on the timing, so we need to supply the water. So for our demo purpose here I'm simply given seconds. Okay, so this 3 is for 3 seconds and 0 is for nothing and 2 for 2 second. So that motor, if our input data is plotted here, means it gives us a label as 2. Okay, so then we need to pass the 2 minutes, 2 seconds of water to that field. Okay, so for example if it was plotted in here, so that I already have a okay, so that have a some moisture content na? So it's already have a some moisture content because it's a invasive method. This moisture sensor and the humidity sensor is an invasive method. So if it is if it detect the moisture content, that values will be low. If it's is did not detect the moisture content, that value will be low, sorry, high. So using by this temperature value and the humidity value and the moisture value and the month, so it's specified as a 0. So because it has a enough much of water, so there's no need of supply the water. Okay, so this is our data set, and here I'm share this I'm transfer this data set into the Raspberry Pi. So in this Raspberry Pi here we have this data set. So the same data set here, so but it is mentioned in a CSV format, but it's so like that some notepad. Okay, so because there is no any Excel file for this Raspberry Pi, if you want Excel some office man, so we can install it. Okay, LibreOffice is one of the application for accessing the our Microsoft Office. Okay, so this is the data sets, our data sets. Okay, so let's run the program. So and before that I explain it clearly. So this data set, this all the data set is read by using the read CSV function. Okay, so using by the pandas and read CSV, this all the data is stored to the DF, and from this DF here I'm simply drop the water. So drop the water means this is the label, our final answer. So here I'm drop the water, and remaining all the features are stored to the X. Okay, so this drop is used for data cleaning. Okay, so and this water, so here we didn't using any functions like drop, so that's why these all the values under the water is stored to the Y. So this X has a features and this Y has a X has a features and Y has a some labels. Okay, okay, so now after here I'm simply given KNN variable, and this KNN variable is mentioned as a K neighbors classifier, and to this KNN here I'm fit the label features under the labels. Okay, so for training purpose, so because this is our experience, this experience data is given to the algorithm for training, so that's why I'm using this fit. And after that, so for for getting a input, that real-time input, we need to get the values from our cloud. Okay, so that's why here I'm called the ThinkSpeak cloud. Okay, so using by this channel and ID and the API key, read API key, so we can get the data as a JSON format. So based on this JSON format, from this JSON format we can extract these values using by the data slicing method. So that's why temp is equal to int of data of field 1. Okay, so if because we are applying the temperature value into the field 1 and moisture value into the field 2, so here we take the, here we get the data from field 1 that is stored to the temp. Okay, and field 2 and field 3. Okay, and finally, so this is one of the process for getting a timing. So here we are in need of giving us some manual input for the timing process. So because this is a some demonstration, that's all. Okay, if you are apply this concept into your product and if you are fit this into your agricultural land, so that will automatically calculate the timing purpose of planting. So sorry, timing period of planting. Okay, but now, so this is for only the prototype and it's for demonstrations. So we can't get the month wise calculations now, so that's why here I'm give the manual month. Okay, so that's why I'm using the input of, so int of input of how many months is it from planting, so it will be stored into the timing. Okay, that's all. So and after that here I'm apply this all the values into the numpy, and it was converted to the second two dimensional, and this two dimensional was converted to the array format, and this value is stored to the xtest, and using by the data frame, here we convert our input data with a some excel format. Okay, so and then here we apply our xtest into the prediction. Okay, so just run the code, and before that we need to run our sensor updation code, so then only we can get some real time. Okay, so I run that code. At the same time I am going to run this code also. Okay, so just I run that, so it will give us a prediction of how much of amount how much amount of water we need to supply to the agricultural land. Okay, so how many months is it from planting, so here I'm simply give a 1 month from planting. Okay, so see, our input moisture value is a 1007, and temperature value is a 68, and humidity value is a 1009, and the planting time is a 1 month. Okay, so for this input data, here we get a output as a 2, so 2 seconds of water supply is enough for this condition. Okay, so this is the our machine learning output. Okay, so now after that we need to interface with a some actuating method. So this machines, it's perfectly analyzing how much amount of water we need to supply to the field, and after that we need to give us some command to the actuators also. So that's why here I'm already, as I'm told already, we are using the some pumping motor using by relay. Okay, so and this is the digital output. So for this process here I'm simply IO. Okay, so I am given import rpi dot gpio as gpio. Okay, so and next gpio dot set mode, because our gpio has a two types of modes, busy mode and the board mode. So I am using the BCA mode for our process. So and next, so it has a 26 number of GPIO pins, so we need to choose the pin using by the setup function. So GPIO dot setup of, so here I am choose the 21th pin as a our output pin. So GPIO dot out. So that's all, and simply I give a GPIO dot set warnings false for avoiding the warning. Okay, so finish, and after the prediction, so here I'm give, okay, so give all the values, all the programs into the while loop. Okay, so and I give it to the while loop, so using by the indentation. Okay, so print prediction. So for using this prediction in our other some programs, so we need to identify the type of that prediction. So that's why I'm using the print statement, so then only we can give this into the conditions. so type of okay, so just run that. So set warnings false. So I'm give a 4 month here. Okay, so it's the array format, so we need to convert this into the list. Okay, so print list of prediction. So prediction is equal to a list of simply change that. Okay, so just run that again. Okay, so now it's a list. So and we can get this the exact value from this list using by the some positioning method. So I'm print the period of 0. Okay, so it's a 0th position, so that's why I give that. Sorry, so in a square bracket we need to mention it in a square bracket now. Okay, so finally we get a some string value. Okay, so using by these string values, so we need to give us some if conditions. Okay, so if, so finally I change this with a data is equal to prediction of. Okay, so if data is equal to 0, if it is a 0 means we need to supply the water for, sorry, we don't need to supply the water, so that's why I am simply give a GPIO dot output of false. So false means that motor will be in a off conditions. Okay, so and then elif data is equal to 1. Okay, so 21 is our motor pin. So we need to on the motor for a 1 second, so that's why I'm simply using the time module file time dot sleep of 1. Okay, so as like if it is a 2 means, okay, so if it is a 2, it's take a 2 seconds time delay, and GPO dot output of and after 2 seconds it's need to in a off condition. Okay, so false. Let's say 3 seconds means it is 3 seconds, that's all. Okay, and else, so if the data is out of these values, or we need to off the motor as well. Okay, so gpu dot output of 21 comma false, that's all. And here I'm simply give this into the try. Okay, an exception. Okay, so that's all. So let's check this with our hardware. And before that I will check the program, is there is a right or wrong, sorry, is there is any error applicable or not. Okay, okay, so till now there's no any error here, so just I'm give it 2. Okay, so it's some technical error. Okay, so we need to of data. Sorry, yeah, we need to. Okay, so let's check that. Okay, okay, so this is the output. Okay, so just change this the string. Okay, so string of output. Okay, so I converted to the string, and now let's check this with a OP. Okay, so that's it. So just see the motor here. Okay, so now I'm delete the try for identify the error. Okay, so we need to import the time. So that is our error. Just I give it 2. So that motor will be on for 2 seconds. Okay, just connect it to the motor pin 21. Okay, so now this motor pumping up with a 2 seconds. So 2 seconds water supply is here. Okay, so now check the moisture content. So see, so because this plant has a moisture level, so that moisture level is reducing here. Okay, so I think, so did you see this clearly? So if you did it means just mention it in the chat box. I will run again. Okay, So I will run it again. So I give another one data, and before that, so I hope now can you can see clearly the pumping. Okay, so again I give them some 3. So did you see? So there is a 1 second is enough for that, so that motor will spray the water for 1 second, that's all. Okay, so if it is a again it's a 3 means it's again it's a 1, so 1 second that water will be supply for that agricultural land. Okay, yeah, okay. So if you have any doubt about this, then just mention it in a chat section. Okay, so let's conclude this session. So that use of these emerging technologies, so that artificial intelligence and the internet of things will allow the industry to successfully see many benefits, such as reducing the cost and wastage, and water wastage, and achieving the great sustainable practices. So this IoT and the artificial intelligence will be essential for the agricultural industry, so to keep up with the growing populations, of making it possible to meet the required needs, so required production and productivity increasing. Okay, so in the sessions today, so we are start up with some informations about smart agricultures, and what are the uh, need of embedded systems, and what are the need of artificial intelligence, what are the need of IoT in this agricultural land. Okay, so this is a very, very simple demo. Okay, and as I'm told already, this artificial intelligence was as a many more specifications. So it created the so another one revolution in a agricultural world. Okay, so if you are just educated with a smart agricultural machines, means you can get a lot of list of machines. So there is a lot of machines are available for smart agriculturing. Okay, so and these all the machines are only running by the artificial intelligence and the internet of things. Okay, and guys, if you like this video, so just click a like button. So just I'm waiting here for your response. Okay, so I want to know about my content, so that's why. So just if you like this video, so hit a like button, so otherwise you can dislike it. So I'm waiting here for your response. So just so give a like. Okay, so if you like this video, and share this with your friends and your colleagues for getting a more information about this artificial intelligence and IoT in agricultural field. Okay, so now 334 participants are here, so watching now, I think. So only 300 is response here. So okay guys, so we need some feedback. Okay, so just give your feedback about this session. So in that comment section, so not in a chat box. So after uploading the video, so you can get the comment box. So and in that comment box, kindly give your feedback. So here there is a lot of doubts are there, so I clear one by one. Priyadarshini, please share name of the simulation software. Oh, that circuit making software. So that is a fritzing. So fritzing is a software for circuit connections. Okay, and next Deepanara, can we use fritzing tool for ML algorithm implementing RPL on? So no, we are cannot using this fritzing tool for ML algorithms. This is for only the hardware purpose. That's all. Sandanu Chakraburi, how do we collect agricultural data? So that's I'm told. So here we using the sensors for collecting the data, and this data is used to send to the cloud by the ThinkSpeak and the some MQTT protocol. Yeah, and again MQTT broker is a sensor which is connected to cloud. So simple. So here we using the sensor. This sensor is getting a sensor's data, and this sensor's data is uploaded to the MQTT broker. Using by this MQTT broker, that broker publish this data to the subscribers. So that's all. So there is no any interconnections between the sensors and the MQTT broker. That data only shared to the MQTT broker. Yeah, yes. Are we using a Raspberry Pi as a processor? Here, yes, definitely we are using the Raspberry Pi as a processor here. So because why we using this Raspberry Pi means, so if you would take a Arduino, so because we can't sorry, we can connect the these types of sensors and actuators in Arduino also, but this is only for getting the data and uploading the data, that's all. So we can't apply any one of the highest processing means open image processing or data analytics or data science method in the Arduino. But this Raspberry Pi gives us a both of that. So we can interface the sensors using by the GPIO, and we can do the some image processing and the data analytics process. So using by that specific processor, BCM processor. Darun Nair, what if we can't separate the classes elements to two or more distinct groups? We can give a more number of classes. That's not a problem. So but so based on that classes, you need to give a more amount of features also. Can we use any another microprocessor for AI in IoT? Darunim Noira. So we can use another some processors. There is a lot of processor available as like Raspberry Pi, so Banana Pi and Orange Pi. So and you can take a ARM 11 controller, sorry ARM controller also. So using by this controller, we can do our machine learning processes. Okay. So but this is a very special one. Raspberry Pi is a special one. So it's enough for this process. So when we compare with other some processor, this is a very low cost processor, I think. So when you compare this with a Banana Pi and Orange Pi, so this is a very low cost. So and guys, so if you are like this video, kindly hit a like button. So and share this with your friends. And if you're new to this channel, kindly subscribe us for getting a so some knowledge growing of some latest trending technologies oriented. Okay, and click a bell icon for getting a notifications about our upcoming webinars. Okay, and if you want a further details about our webinar and this class, or if you want any further details, more details in online internships and the in-plant trainings, so that like means, so just contact our coordinators, so through this mobile number and the mail id, so 9746742936 and novitechquestion@gmail.com. Okay, thank you for your response. And once again, I thank all the participants like faculties, students, and industrialists and research scholars. So and especially very thank to the organizers of Bannari Amman Institute of Technology, so EC department,